In the previous video, we saw what will happen on Earth and in the universe over the next billion years. But the events don't stop there. In 1.5 billion years, due to the Sun's increasing luminosity, the habitable zone will have shifted outward. As CO2 increases in Mars's atmosphere, its temperature will become increasingly similar to that of Earth during the Ice Age. By then, the Moon will have drifted so far from Earth that it will barely maintain its rotational stability, and consequently, the planet will become even more chaotic. In 2.3 billion years, Earth's inner core will have grown so large that the liquid in the outer core will freeze, causing Earth's magnetic field to cease to exist. In 2.8 billion years, the planet's average temperature will be around 147 degrees Celsius, even at the poles. It will be then that the very few remaining single-celled organisms, which survived in high-altitude lakes or caves, will have become completely extinct. And in about 3.5 billion years, the water in the oceans will have completely evaporated. The greenhouse effect caused by this water-rich atmosphere, along with the increasing luminosity of the Sun, will cause the Earth's surface temperature to rise to 1,130 degrees Celsius, enough to melt some rocks. And a little later, Neptune's moon Triton will have come so close to the planet that it will disintegrate into a ring system, similar to Saturn's. And in less than 5 billion years, the Andromeda galaxy and the Milky Way will have collided and merged into a larger galaxy named Lactomeda. But the most surprising thing is that the planets of the solar system will most likely not be affected by this event. Furthermore, our Sun will have exhausted the hydrogen supply in its core and will begin to evolve into a red giant, reaching its peak in 7.9 billion years, with a size 256 times greater than it is now. During this process, the Sun will have engulfed Mercury, Venus, and very likely Earth. But it's not all bad news. As Earth gets ever closer to the Sun, the Moon will likely disintegrate, leaving Earth with a beautiful ring that will gradually fall onto the planet. Moreover, we could be witnessing all of this from Saturn's moon Titan, as it will reach suitable temperatures that will make it habitable for humans. However, our new home would soon cease to be pleasant, as the Sun will then become a white dwarf with half the mass it has today, causing a temperature collapse throughout the solar system. In about 100 billion years, the expansion of the universe will have moved our small local group so far away from the rest of the galaxies that they will no longer be part of the observable universe. We will be surrounded by absolute darkness. Furthermore, our local group will begin to merge into a single galaxy over time. In 4 billion years, the closest star to the Sun, Proxima Centauri, will also become a white dwarf. In 100 billion years, star formation will cease due to the lack of hydrogen, and those that remain will slowly exhaust their fuel until they die. In about 120 billion years, all the stars in the universe will have run out of fuel. The only objects that remain now are brown dwarfs, white dwarfs, neutron stars, and black holes. Additionally, collisions between brown dwarfs will create the occasional red dwarf. In our galaxy, approximately 100 stars will remain shining, a far cry from the 100 billion stars that exist today. In 10 trillion years, most of these objects will have been ejected from galaxies. The Milky Way will then be almost devoid of objects. And in a quintillion years, the few remaining objects will have fallen into the supermassive black holes at the centers of their galaxies. Gradually, all that will remain in the universe are black holes. But a point will come when even black holes will evaporate, and our universe is suffering heat death. There is no more free energy for any process. Nothing is happening anymore. The universe has died forever. Was it all worth it?